Hello everyone, welcome to Ekeeda platform, and this is Ravindra here, your electrical faculty. And in this video, I'm going to talk about the Thyristor and its different characteristics. So before that, I will discuss some of the points which are related with the Thyristor family. Okay, I will talk about the Thyristor families. Various semiconductor devices are included in this. So let's proceed one by one. If I talk about the power semiconductor devices which are operating, so these are actually operating in the switching mode. I will discuss in further slides. So they can easily handle the high voltage and currents. Okay, so they can easily handle the high voltage and currents. Now, wide range of rating. If I talk about the controlling ability and the power transfer capability of these devices, then these are having the wide range of rating, and this is actually from 1 kilowatt to 100 megawatt. 1 kilowatt to 100 megawatt. Okay. Now, Thyristor is generally general name for all the 4 layers. We generally have the 2 layer and 3 layer, 2 layer and 3 layer seams. And if we talk about the 4 layer seams in the power devices, that is the PNPN. That is PNPN. It is having the 4 layers, 1, 2, 3, and 4. These are the 4 layers. So it will include HCR, silicon control rectifier, TRIAC, LASCR, and GTO. These are actually included in this. Okay, with the new technology, the power capacity is increased. The power handling capacity of these devices with the new innovations and the development is actually increasing, and also it is kind of economical operation we can see here. Kind of economical operation we can see here. So the high power LSCR developed mainly for HVDC and static VAR compensations. Static VAR compensations. If I talk about the recent developments which are related with these Thyristor technologies, are actually if we talk about for the GTO, that is actually gate turn off Thyristor, gate turn off Thyristor. Then I can say the rating of GTO is actually the 5 kilovolt and the 3000 ampere. 5 kilovolt and 3000 ampere, and that is actually causing the elimination of commutating circuits, so we does not require any commutating or the force commutation. I can write does not require force commutation technology. Commutation, I can say technique, because and GTO, in the GTO we are having, if I talk about this GTO, then we are actually having the gate signal terminal. If I talk about the gate signal terminal, so we does not require any additional type of so that we have to do additionally turn off our thyristors. It is having the gate terminal. By using the gate terminal or by variation of alpha, that is the firing angle, we can turn off our thyristors easily. Now we are moving for next. If I talk about this table is actually representing the ratings, the various ratings of the devices in the various perspectives. If I talk about the diode, okay, so the maximum voltage value of this diode, I can say the 5000 volts, and the for the thyristor it is 6000. For SiC it is 2500 MCT. All we will discuss. We do not have to study all of them. We only required to know about LASCR, GTO, IGBT, and mostly we have to know the IGBT. Okay, because generally and nowadays we are actually using this an advanced technology, that is the IGBT, insulated gate bipolar junction transistor. Now, if I talk about the single unit current ampere, that is the 600 to 800 for the thyristors. SiC it is 800. Okay, and for the MCT is 400. GATT the 400. Okay, 800, 650, and 800, like this. we need to know the maximum current capability it can handle. So for the diode it is 5000, for the thyristor it is 3500, for SiC 800, and for GATT that is the 200, 2500, 3000, and here 3000. So maximum, I can say that the maximum current which can diode, which can handle, which can be handled by, that is the diode. So which is actually the 500 ampere, and which is the maximum value. So maximum current that can handle a device, and that is the diode. The typical frequency, if I talk about the switching frequency, not the switching frequency, if talk about the maximum frequency for these devices, then it is 1 kilohertz for the diode, 0.5 for the thyristors, and LASCR it is 1, and GTO for the 2, and the IGBT is 2. So I can say the GTO and IGBT are more preferable if we talk about the maximum frequency. If I talk about the switching junction temperature, so that is actually comparable, okay, that can be handled, that is actually comparable. But if I talk about the IGBT, it can handle from minus 20 degree to 150 degree, minus 20 degree to minus 150 degree. So I can say it is a large value. I can say it is a large value. 1 second, I can move it upward. Okay, it cannot be handled. So I can write if it is not visible. So for the IGBT, I can write that is for the switching junction temperature. For the switching junction temperature, it is actually from minus 20 degree to 1 plus 150 degrees Celsius, and that is actually a huge range as per other power semiconductor devices. Okay, now we are moving for these constructions or this representation as per the diagram. If I talk about the conventional thyristor, so it is look like this, circular shape, and having this type of design. This is a GTO, this is IGBT, high power devices. Actually IGBT have the 4 module and the 6 module system fabrications. Okay, direct light triggered, okay, that is a LTT. I have already talked about DLTT. This is look like this. Okay, integrated computed thyristor, that is IGCT. Okay, and this is the IGBT, high power devices, and this one. Okay, so I hope you have understood up to this point. Okay, now we are moving for the next slides. Okay, now if I talk about the silicon controlled rectifier, okay, in this sense, if I talk about the silicon controlled rectifier, it is actually a SCR. What is it? Is SCR, and in general it is having a various types of thyristors. Okay, but if I talk about the SCR, that is the silicon controlled rectifier, so that will be generally called as a thyristor, and it is written here that in general it will be called as a thyristor. So whenever we talk about, or whenever we say that what is the thyristor, so generally one thing come in our mind, that is the SCR, that is the silicon controlled rectifier. Okay, now that is a thyristor, which is now we can say that SCR is actually a 3-terminal, is actually R3 terminal and the 4-layer device. Okay, 4-layer device, that we have to remember. It is having 3 terminals. And what are these 3 terminals? Okay, it is saying that 3 terminal and the 4-layer device, and these terminals are, the first is your anode, second is your cathode, and third is your gate, and we need to remember this. As in the diode, if we talk about the diode, and then we had one anode terminal which is a positive potential as compared to the anode one, as compared to the cathode one, that is the K, and it is maintained at negative. Or you can say the anode potential is more or higher as compared to the cathode one. Okay, now so I can say that it has the 3 terminals, and which are the anode, cathode, and gate. Anode is actually at the higher potential, and cathode is at the lower potential. So if I talk about the forward bias, so it may have the 2 schemes, the forward bias schemes and the reverse bias schemes, as in the transistors and the diodes. But when we talk about the forward bias schemes, then that anode is actually is in the positive potential with respect to your cathode. Okay, now I will talk about the SCR in the reverse bias. If I talk about the SCR in the reverse bias, then it is clearly mentioned that anode is in the lower potential with respect to cathode. In the same way, the anode is here in the forward bias, it is in the positive potential. So whenever, as we have seen in the diode, whenever we have the forward biased, it means obviously we are going to use as a closed circuit. Okay, ideally we will use as a closed circuit. But when we talk about the reverse bias, it means it is going to be a it is going to be in the open circuit condition. There will be no current will flow from anode to cathode. Okay, so that is its representation. So at the lower potential cathode, so as per the biasing scheme, so there are the two biasing scheme, the forward biased and the reverse bias. If we talk about the forward biased, then SCR behaves as an open circuit. So I can mention here in the forward bias schemes, if I talk about the forward bias, so SCR will behave as a open switch. It will behave as a open switch. But when we talk about the reversed bias, then it will behave as a sorry, I have written wrong one here. I can omit that. If we talk about the forward bias, then it will behave as a closed switch. And if it is reversed bias, then it will be obviously your open switch. In open switch, there is no flow of current. Okay, now, so that is for the biasing scheme. So it is written the SCR behaves as an open and the closed switch as per our bias scheme. So biasing is actually two types, that is the one is the forward biased and another is the reversed bias here. Okay, now it is having the fast switching action. So as we have replaced the mercury arc walls, and now we have used the silicon controlled rectifier for our HVDC transmission controlling purposes. So as it is having the fast switching action, so it is replaced. So why it has replaced our mercury arc walls? Because it is having the fast. So one advantage is that it is having the fast switching action. Another advantage is that the small size, it is having the small size, compacted size, compact, it is having the compact design. Okay, and the third point I can write that low voltage rating. Okay, it is having the low voltage rating. So these are the points I have discussed about the silicon controlled rectifier, that is the thyristor generally called. Okay, now we will move for the next point. So before talking about the static VI characteristic, I can draw here the basic fundamental diagram of this or representation. Okay, so this is like this one. Now it will have four layers and the three terminals, and which is P, N, P, N, and here it is anode, and here it is cathode, and it is represented by K. Generally anode is in the positive potential and cathode is in the negative potential. Okay, and from this N we have a gated terminal. From this N we have a gated terminal like this. Okay, so this is the gated terminal, and this gate terminal is actually for our different purposes, for controlling or for firing or gate turn off schemes. These are generally used, and that's why this gating signal, using the gating signal for the turn off, we are generally using the GTO, that is gate turn off thyristor. Okay, so this G is representing the gate terminal, this A is representing our anode terminal, and this K is representing our cathode terminal. This is cathode terminal. So this is the first A point I can write. If I talk about the representation, okay, so what type of representation is this? Okay, it is a kind of diode. It is a kind of diode here, but having a gated terminal. And now this. So again, this is anode, this is a cathode, and this is the gate terminal. Okay, if I talk about in terms of switch, so it is same as I have drawn above, but in parallel with this it will have a switch. Okay, and it is S, so it is anode, gate terminal, and cathode. So this is the fifth, this is the basic configuration. This is C, it act as a switch. So now I can go for the static VI characteristics. So what are the static VI characteristics? The first is actually, if we talk about any thyristors or any, you can say, the semiconductor devices, initially they are in the non-conducting state. So I same here, at first I have written at first, initially they are the non-conducting state. This you have to remember, non-conducting in both the forward, in the forward condition, and the reverse direction. Obviously in the reverse direction it will be in the off conditions. Now as the voltage increases, as we increase the voltage level, as it is seen in this graph, I will show you. So before proceeding to this graph, I want to complete this point. Voltage increases in the forward direction. Okay, so in forward direction, in the sense it will be in the forward biased condition. It will be in the forward biased condition. So this is anode and this is cathode, and we are applying the positive potential, and here we are applying the negative potential. So in the forward direction we are applying, but leakage current only starts to change. Okay, and when the avalanche break occurs, it want to specify that it will only start, the current will only start when there is avalanche breakdown. Okay, avalanche breakdown will happen, then due to this breakdown the large amount of or you can say the current will flow, and due to that flow, that is called the leakage current, I can say. And after the slight breakdown, the SCR comes to the on state, and that we needed. Okay, that is called the forward conduction mode. It is having the 3 conducting mode, and one by one we will discuss in the further slides. So it will have the holding and latching current. Okay, I'm going to dictate this. So you have to remember one thing, this is the holding current, and this is actually represented as IH, and this is the latching current, it is represented by IL. Okay, so this is the on state current, this is the off state current. Okay, it means if the SCR is to be in, if we want the SCR to be in the on state, the minimum current that can flow for the on state, that is the holding current. And what is the latching current? If we want to the SCR to be in the off state, then the minimum current below which it will be off, that is the latching current. Okay, latch. Okay, it has been latched. Okay, you can say. Now if I talk about this VI characteristic curve, VI characteristic curve, if we talk about the VI characteristic curve, then it is having the 3 modes of operation. One is the reverse blocking, second is the forward blocking, and third is the forward conduction. And actually we need the forward conduction for the operations. So one by one I am going to discuss here. Some of the points are discussed here as VFBO and the VRBO. So what is the VFBO? That is the forward breakdown voltage. And what is the VRBO? That is a reverse breakdown voltage. If we talk about the forward, this is the mode 1, that is called the reverse blocking. Here it will happening the reverse blocking. This is the second state, so I can write here, this is your forward blocking. Forward blocking. This is the forward blocking, and this third one is actually, this third is actually forward conduction. It actually depends on the Ig value. If the Ig is 0, okay, then we will increase the value of Ig as so it will go from here to here. Then it will, again I will increase the Ig value. Ig it means the current in the gate circuit, gate terminal. So we had a circuit like this and having this gate terminal. This is anode and this is cathode. So this is the gate terminal. So we will apply the gating circuit, or you can say the gate current we will apply, the gate signal we will apply. So as we increase the gate current, as the gate current increases, okay, so this curve will move up to here, and when it reaches to this point, it means it is a holding current. Okay, so when it is, this is the minimum current, when it is was to start, then it will move to the on state, and this is the latching current below which it will be in the off state. So this is the fundamental VI characteristic curve. If I talk about the three modes of operation of thyristor, three modes of operation of the thyristor, that is SCR, then these are as follows. Reverse blocking mode, so it operates in three modes as name given. Mode number one, that is a reverse mode number one, that the reverse blocking mode, which is discussed here in this slide. Second is the mode number two, which is the forward blocking, and third is the mode number three, that is your forward conduction. So this is the reverse blocking mode, the forward blocking mode, and third is the forward, this is the reverse one, forward conduction mode, in this way. And this all depends on, and this is actually represented by this VI characteristic curve, in which I can say that this is called the reverse blocking mode. This is up to here. Below the holding current is the your second, that is the forward blocking mode, and this is the third one, this is the forward conduction mode, and this it is called as the on state of the thyristor. Okay, so let's proceed one by one, and we will discuss. If I talk about the reverse blocking mode, in the reverse blocking mode, this is the J1 J3 are the reverse biased. Why? What is the J1 and J3 and what is the J2? As it is having the four layers as PN 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 PN, and this is your anode terminal. So I have already told you that it is that is the anode and cathode terminals. Anode is your positive potential or higher potential, cathode is lower potential, okay, or you can say the negative potential. And this here there is a gating terminal which is represented here, and we will apply the gate signal here for the transformations of the signals and for the variation in the modes. Okay, when we apply the it will be positive, and here it will be, I can say, the negative. So I can write here that it is the junction J1, this is the junction J2. What is the junction J2? This one is junction J2, and here it is junction number J3. So it is a four layer, 1 2 3 and 4, it is a four layer, and in between them there is a three junctions. So when we talk about the reverse blocking mode, then this J1 and this J3, what are the J1? This is the J1 and this is the J3. Then this J1 and J3 are in the reversed bias mode, or you can say in the off state, Okay, if I talk about the J2, so what will be the J2 here? It will be in the forward biased. So obviously here what it is going to be, so anode will be in the negative and here it will be in the positive. Okay, so if it is negative, positive negative, okay, here it is negative I will give, then it will be the reverse by, here it will be reverse by, but in between them there will be a positive, and which is your negative will attach to this negative one, and this positive will be attached to the positive one, I can say it is a forward bias. So I can write the J2 is the forward bias, and here it is the reversed bias, and here it is a reversed bias. Okay, now let's proceed one by one. Now third is it behaves as a two diode. So obviously it will behave as a two diode which are connected in series, with the reverse voltage applied across them. Okay, reverse voltage applied across them, and they are behaving as in series. Now I will talk about the leakage current. So obviously when any semiconductor device is operating in the reverse bias, there will be a leakage current, and that leakage current will be in the very small values, and it is written here that is in the microohms, that is actually in the microohms. Okay, now so obviously if it is in operating in the reverse blocking mode, so it will be in the off state, and at the VRBO there will be a breakdown. Okay, so there will be a breakdown. What type of breakdown we can see here? This is a kind of breakdown here. Okay, this is a kind of breakdown here, and at the breakdown here the current will in the negative direction. This is the, here it is a leakage current, and here the huge amount of current after the breakdown will flow. So this is called the reverse breakover voltage, and this is the forward breakdown voltage. The reverse breakover voltage, this should be a breakover, the reverse breakover voltage, and this is the forward breakdown voltage. Okay, now so if I talk about the VRBO, so breakdown will occur, and the large amount of current will flow. Okay guys, now if I talk about the large power dissipation, why the large power dissipation is written here? Because as we know, the power, if we talk about the power, it is a current. Okay, so current here flowing, if we talk about the ID into VD, so in this I can write the current I, and in the voltage, so both are in the high value. Current is also high and the voltage is also high, so both current and voltage high, so there will be a large power dissipation. If there is a large power dissipation, then there will be a heat generation. So if there is a heat generation, then there will be a chances of damage. If I can write here, if a thyristor in off state crosses permissible limit. Okay guys, so if it crosses the permissible limit, so every devices have some particular limit, above that they cannot operate. It means they will behave enormously huge amount of current, or enormously huge amount of voltage. Due to that, the insulation got failed in the power system. So this is the basic fundamental related with that. The thyristor in the off state, if it crosses the permissible limit, then there will be a damage. So this point is representing this. So I hope up to this reverse blocking mode you have understood. Now we will move for the second, that is the forward blocking mode. So what is the forward blocking mode? This is your forward blocking mode. Okay, here, and it means it is in the forward conduction, means the voltage is, anode voltage is in the positive, and the anode current is also in the positive direction. It means it is lying in the first quadrant. So but it is in the blocking mode. Why it is blocking mode? Because no conduction has started till. So this is kind of that. So forward blocking mode. So this is actually called the mode number 2. Generally we represent the mode number 2. So if we talk about the thyristor, so it will be in the forward biased. It means that anode, it will be in the positive potential, and that cathode will be in the negative potential or lower potential, or you can say it will be in the higher potential and it will be in the lower potential. So if we talk about the J1 and J3, as I have already told you that it is have the 3 layers, 4 terminal device, sorry, 3 terminal device, and the 4 layers and 3 junctions. So out of these 3 junctions, this J1 and J3 will be in the forward biased, and this J2 will be in the reverse bias. Okay, as on the applications of as on the application of positive on the anode and negative on the cathode. So if we talk about the reverse bias on the junction J2, then the limits of the forward current, what it does, the forward current, whatever the current is flowing, that it will limit. Okay, it will not provide the certain condition to flow easily. Okay, now the point number 4, that is actually saying that if we have the thyristor and it is in the forward blocking state, what in the forward blocking state, that is the state number 2, then these are the conditions. Now if we talk about the gate current application, okay, so that is the IG, that is called the gate current. So if it has the lower value, like this, so if it is having the, if we have not provided, let us suppose we have not provided, then IG is equal to 0, then we are increasing. Okay, then we are increasing now. So at I can say that at the lower value, or IG at lower, then when IG at lower, then it will remain in forward blocking mode. But when this IG current, it is increases, then it will be now in the on state, and that on state is called forward conduction mode. Okay, now I will talk about the third point. Okay, so third point is forward conduction mode. If we talk about the forward conduction mode, then it is called the mode number 3. This is called the mode number 3. After the forward blocking mode, then we will see the forward conduction mode, and in the forward conduction mode, here the same configuration is the forward blocking mode, but we have increased the IG current. So I can write that IG current is increases to such a value that it crosses holding current, the holding current. So, and above holding current, I can write above the holding current, above the holding current, the thyristor will be in the in on state. That you have to remember, on state. This is the basic functioning. Okay, so we have to remember all these points, and for making it is in the on state, we have some methods. I can write the first is gate triggering method. Second is irradiation. Second is irradiation of gate and cathode voltage. Third is dV/dt rating of circuit breaker, by varying dV/dt rating of, not the circuit breaker, of thyristor. Okay, and fourth is using the VFBO, forward blocking over voltage increasing. Okay, like this. So here it will also be avalanche breakdown and the huge amount of current will flow. So you can see in this characteristic, you can see in the characteristic of that, above the holding current it will enormously increase, okay, like this. So this is all about, this is the reverse blocking, forward blocking, this is your forward conduction mode. So I hope up to this point you have studied successfully, you have learned all about the basic functioning of the thyristor. So tata, bye bye, and see you in the next lecture. Bye bye.